So, today we will discuss about the RC circuit, electrical circuit. So, generally we are quite familiar with the electrical circuit where we just use resistance. Now, resistance, resistor, capacitor and inductor, these three are very important component, electrical component. So, now all the time in a circuit resistance will be there. Now, if we add capacitor in that circuit, then what happens, that is what we want to study. So, basically we tell this in RC circuit, this charging and discharging of the capacitor. So, that is the interesting variation of voltage or current in the circuit across the capacitors, So, we will see that with time, so this current and voltage across the capacitor is not constant, it varies with time. Okay. So, how it varies with time, so that we would like to see. Also, in case of say charging, in case of discharging also similar things, this how current and voltage varies with time in the circuit. So, that we would like to see. Now, in this circuit, this time constant is very important factor. So, that also we will try to find out the time constant of shear circuit. Okay. So, let us discuss theory first of this experiment. So, actually we will try to find out the time constant of a RC circuit by charging and discharging method, right. So, this is a shear circuit. If you look at this part, so in a circuit of course you need DC power supply. Okay. So, we can use battery, but here we will not use battery, we will use constant voltage source. We can vary the voltage, we can choose the voltage as you wish, but in case of battery, so you cannot change the voltage, but there are voltage divider circuit, so that you have to use to vary the voltage. So, you have a voltage source, so it will give you constant voltage. Now, this the circuit, RC circuit. So, this RC circuit, so one end of this circuit, is connected to the power supply. Say it is connected with negative of power supply, and this other end. So, this CR circuit. Now, other end here we have two options. One option, this a switch. So, if it is connected with one, then circuit it is going to the power supply, say this positive terminal of the power supply. So, then when the switch is at position 1, so then it is a shear circuit, and power supply is connected with this circuit. So, current should flow through this circuit. Okay. Other option is this: if you put the switch at position 2, then complete circuit will be this, So, this is also shear circuit. Now without power supply, without applied voltage, so then what will happen in the circuit? So this we tell discharging. So when this switch will be at position 1, then it's a charging of this circuit, shear circuit, and when the position of the switch is at 2, then it will be discharging of the circuit shear. Okay. So in both cases, charging and discharging. So here we have connected voltmeter. So across this capacitor, how this voltage will change, that we can find out. And also we can connect here one ammeter, okay, one ammeter. So in both cases again, this during charging and during discharging, how current behave in this circuit, that we can find out from this ammeter. So ammeter and voltmeter. Ammeter is basically will give current variation in this circuit during discharge and charging and discharging time. Also we'll see the variation of voltage across this capacitor during charging and discharging. Okay. So let us see theory. So when S is connected to the 1, then this is charging. Okay. So at time t equal to 0, so charge on the capacitor is 0, Q equal to 0, right. So now just at time t equal to 0, just it is connected, or we are going to connect. Okay. So that means is a charge, this in capacitor is 0. So that's why this is the boundary condition, initial condition. Now if you connect it, so what will happen? So this is the circuit, and in this circuit, so you can write what will be the voltage drop in this circuit. So voltage drop across the resistance. If current in this circuit is I, so voltage drop across the resistance is IR, and voltage drop across the capacitor, so that will be Q by C. That will be Q by C if charge is accumulated in this capacitor, that is Q, and if C is the capacitance, so Q by C, that will be the voltage drop across this capacitor. So this voltage drop across the resistance and across the capacitance, so these two will be equal to the voltage to the source. So that will be equal to the V0, right. So current I is basically dq by dt, change of charge with time, dq by dt. So now this I can replace with dq by dt. So then equation I am getting dq by dt plus q by divided by r. So r and c is there. Q divided by rc equal to v by r. Okay, so I divided by r and replace I with dq by dt. Okay, so now this just I can arrange. So v0 by r I can take this side, and 1 by rc. So this I can write q minus v0c, right. Q. So these two terms will give me q minus v0c. And here this is the differentiation with respect to the time. So q dq by dt I can write d by dt of q minus v0c, because v0 is constant and c also constant with respect to time. So d by dt of q minus Vc is equal to dq by dt basically. So, I have taken in this form, then this is just like dy by dt plus 1 by Rc y equal to 0. This is the first order homogeneous equation, and its solution is, you know, this one can write general solution y equal to a e to the power minus t by Rc here. Okay. So, this y equal to whatever this mx mt q is a function of t. So, t is there. So, this general solution of this will be, so this e to the power minus this whatever this m is there here. So, m t. Okay. So, m is 1 by Rc. So, this so y equal to q minus v0c, q minus v0c, q is a function of time basically. So, if you put this boundary condition at t equal to 0, q equal to 0, so you will get basically value of a, this is a arbitrary constant equal to minus v0c. Okay. So, ultimately you are getting just replacing a by minus v0c, you are getting qt, q is a function of time equal to q0, q0 is v0c. Okay. So, this you know q equal to cv, right. So, it is the q0 because this when it is fully charged v0. So, this fully charged means then its voltage across this capacitor will be v0. So, then it is the full charge in the capacitor, that will be q0. So, q0 1 minus e to the power minus t by Rc. So, charge in this circuit or this in capacitor, okay, will vary with time. So, variation of charge in the capacitor, okay, or in this circuit will be like this. Okay. So, q equal to q0 1 minus e to the power minus t by Rc. Now, if you know this one, so if you divided by c in both sides, so this will be variation of voltage. Okay. So, you will get Vt, you will get Vt, okay, you will get Vt equal to V0 1 minus e to the power minus t by Rc. And this you can find out the variation of current. So, IT, I is a function of t, will be dq by dt. So, if you differentiate it, so ultimately you are getting IT equal to I0 e to the power minus t by Rc. Okay. So, from now you have expression for variation of charge in the circuit or across the capacitor. You have variation of charge Q, variation of voltage V, variation of current I. So, all are varying with time t, and how they are varying. So, this expression is in your hand. Okay. So, now if you plot, so this equation is telling that this current in the circuit will vary, okay, will decay with time, from at t equal to 0 it will be I0, at t equal to 0 it will be I0. So, current will vary during charging. So, starting from I0, it is the time t. Okay. So, variation is exponentially it will decay, right. So, with time current in the circuit will change like this. Okay. And voltage here 1 minus this part. Okay. So, at t equal to 0, this voltage is this will be 1. So, V will be 0, V will be 0. Okay. So, if I plot voltage, Okay. So, initially at t equal to 0 it will be, now then this term is decreasing like this, okay, decreasing like this. So, this term is decreasing with time, so then 1 minus this, so this factor will increase, okay. So, with time this variation will be exponentially, it will increase, okay. So, this variation will be like this, okay. So, this will be, here I can draw this the, okay. So, this value will be basically V0, this value will be V0, this is I0, and it will decay exponentially. So, yes, so this basically I have plotted IT and this I have plotted VT, right. So, now here it is a decreasing either current or voltage or charge, okay. So, basically measuring charge is difficult than the measuring voltage and current, okay. So, that is why I am not plotting this charge. So, but in principle if you have this plot you can just find out the variation of charge, okay. So, multiplying with multiply or divide by C and R. So, now interesting thing is that if you see that if t equal to RC, if t equal to RC, so this factor is always, this factor is, so this one t by RC, when t equal to RC, this is 1. So, this factor will be 1 by E, this factor will be 1 by E, okay. So, in this case 1 by E times I0, in this case 1 minus 1 by E times V0, okay. In case of charge also you can find out, in case of charge also this factor is here, if t equal to RC, so this factor is 1 by E, this factor is 1 by E. So, here also whatever the way voltage is varying, so the same way this charge is varying, okay. So, this variation of charge with time. So, this charge is, as voltage is increasing, so also charge will increase same way, okay, and it will go towards the Q0 value. So, here when, so t equal to RC, what does it mean? T equal to RC, so that is basically RC is time. So, at that time what will be the value of charge in the circuit, okay. So, charge will be during charging, here during charging it is, here it is showing the charge will be 1 minus 1 by E times of Q0 or 1 minus 1 by E times of V0 or current will be 1 by E times I0, right. So, whatever the case, either voltage or charge or current, so 1 by E times or 1 minus 1 by E times. So, this, this 1 by E times is very important, it seems, right. So, let me come just after discussing this discharge. Now, when, so this S, this switch is connected to 2, the switch is connected to 2 at this point. So, this there is no battery in this circuit, power supply in this circuit. So, this we tell. So, already this it is charged, okay, after fully charge of this capacitor. So, if I connect this one, so now we are telling these are discharging of this in this circuit. So, discharging, then you can write, because this, then IR plus Q by C equal to not V0, is 0 because no power supply. So, in case of discharging, so this will be the equation, and if you just proceed as we did in charging case, So, you will get Q equal to yes, Q0, CV0 means Q0, okay, Q0 e to the power minus T by RC. So, just here this form is same as the in case of current for charging. In case of current for charging, so this just in case of discharging, the charge follows the same form of this current in the charging case. So, this equation, its the variation will be so like this, okay. That means charge will decay exponentially, and corresponding voltage expression is this. As I told, the charge and voltage variation will be in same way, variation will be same way. So, this basically it will vary, just decay with time. So, charge and voltage, okay, it will decay with time. On the other hand, this current you can find out IT dq by dt. So, this is a minus I0 e to the power minus T by RC. So, whatever the so in case of discharging, so initially current basically 0, okay. So, now this current is also exponentially it will decay, but it's the negative sign, okay. So, basically here it is telling current will flow in opposite direction during the charging. During charging, whatever the direction of the current, so during discharging current will flow in opposite direction, and variation will follow this, okay. So, from actually yes, yes. So, this is the variation, exponential variation, but it is with negative sign. So, here also when t equal to RC, so again 1 by E times of I0 or 1 by E times of V0 or 1 by E times of Q0, okay. So, what does it mean? So, this we tell, this t equal to RC, this we tell the time constant of this circuit, So, its significance of this time constant is that this, from here you can see that whatever the during discharging, whatever the charge was there, fully charged Q0, so to decay this current to decay this charge Q0 to 1 by E times of Q0, okay, decay to this charge equal to 1 by E times Q0 to this value, this time it will take, that is called the time constant, and that will be equal to the RC, okay. So, in case of this one, in case of voltage also similarity, so to decay from V0 voltage, when it will, the time it will take to decay to the 1 by E times of V0, so that time is called time constant, okay. So, during charging also, to charge, so initially it was this charge or voltage was 0. So, to charge the capacitors at the value of 1 minus 1 by E times of V0 fully charge, okay, full charge V0. So, to charge it up to that time, okay, how much time it takes to charge it of 1 minus 1 by E times of full charge or full voltage, okay. What is the time it takes? So, that time is called the time constant for this circuit, and this time constant shall we tell tau equal to RC, okay. So, that RC you can measure, we want to measure. So, in this experiment actually we want to plot the current as a function of time, voltage as a function of time during charging as well as during discharging. And then from this variation one can find out the time constant tau. Okay. So, for that generally we plot log, we use log plot. So, if you take log say here, okay, so you will get log I equal to log I0 minus T by RC. Okay. So, if you plot this log IT as a function of time, so you will get a basically straight line. Okay. So, from the slope, so because minus 1 by RC into T, so it's a like okay. So, IT equal to, I am getting here minus I0 will be some so log I0 plus, not plus, in this case it will be minus 1 by RCT. Okay. So it's a kind of y equal to mx plus c, right. So m is slope and that m will be, this m will be basically 1 by RC. So just inverse of the slope will give you the value of RC. So we will plot logarithm, we will use logarithmic plot and then we will find out the slope, and inverse of the slope will be the time constant for this circuit. Okay. So this is the purpose of this experiment. So I will stop it. Thank you for your attention.